From this video, we will solve conservation laws, or we will develop formulas for the conservation laws. And you remember that from the conservation laws, we mean that some equation which is written in this form. But remember that we also need to put the value of f of qt over here. For example, if fqt is u bar q, then we have advection equation and so on. So in this video, we develop simple formula. Maybe we will talk about that, how to develop the numerical method. Imagine that we have a domain. This is a physical domain. This physical domain is discretized, or we have made some points. These are the points. Pick some random point. For example, if we have this I and the neighbor is I plus 1 and the left neighbor is I minus 1. And we also pick one intermediate value from these two neighbors. Suppose that we selected a center of this cell, and we also select this value from these 2 points, I and I plus 1. Since this is a center of these 2 values or points, then we call it I minus 1/2. The right neighbor is I plus 1/2. We call this cell, which is called cell, and its name is cell I, as a volume. Although this doesn't look like a volume, but if this is a interval, we can have the directions, or we can have length in other directions, or maybe width and height, which is equal to 1. In that case, this becomes a volume with width is equal to 1 and height is equal to 1, and the length is equal to delta x. So you can see that we are talking about finite volume method. Similarly, if you write, for example, if you draw another imaginary line over here, then this becomes I plus 3/2. Now this cell is called cell I plus 1. It can be called a cell, it can be called a volume, and this is called cell I, so on. So we can define all the cell like this. This is cell I plus 2. Okay, I hope you got the point. So we define, for example, Ci, which represents a cell or volume, xi minus 1/2 xi plus 1 half. So this one is the Ci. Now our aim is to approximate the value of this Q. Q is our solution. Q is our solution. So we need to approximate that. From calculus 1, we have one definition of average. Average of F is defined as 1 over B minus A to B, F of x dx. Or we have, for example, A to B, and there is any function, but we want to find the average of that function. We want to know the average value of this function over the interval. Similar concept can be applied over here. For example, we have this length is delta x. So it means that if we integrate a function over solution qx tn dx, remember that we are discussing our problem at level n, time level n. So we integrate this function over xi minus 1 half, xi plus 1 half. And the average value of this q over this interval, this volume, is 1 over delta x, which shows the length of this interval. So that value will be equal to, since on the right hand side we took the solution at nth level, so that will give us approximate value of this q, small q, at nth level n. And as I already discussed, this cell is called I, so the value is at cell I. So that's how we define a value, approximate value of q. This will not be equal to exact, but this will be approximated value over here, over this interval. Since I will use this value xi minus 1 half to xi plus 1 half, this interval, so what I do, I actually introduce the ci over the integration. So qn I approximately equal to 1 over delta x ci qx tn dx. So qni means solution, numerical solution at nth level for cell I, at cell I. Similarly, if we have ni minus 1, so it means that we have a solution, numerical solution at nth level on cell I minus 1. Again, If, for example, we have I plus 1 and n plus 1, so it means that the solution is solution at n plus 1 for I plus 1 cell. That's how we define the numerical solution. I hope you got the point. Okay, so how will this look like? For example, for this cell, the value will be Qni at nth level, and for this new cell, the value will be for Qni plus 1, and if we have another imaginary wall, then that will be Qni plus 2, etc. Okay, so this was all about the definition of the approximate value in finite volume method. In the next video, we will talk about the order of this approximation. Order of, there should be some value Ci, it is already there, okay. So we want to see the order of this method in next video. Thank you for watching.